Okay, so we are starting Unit 2. This is Lesson 4, Session 1. And so the objective for this session is that students will be able to perform dilations using a scale factor. So before we can start, there's a few vocab terms that we need to kind of break down so that you understand what we're doing. So the first one is, what in the world is a dilation? So this is our first vocab term. We're going to put that in a box. And so a dilation is a transformation. A transformation that creates a similar figure. Now, it's not a rigid transformation, right? So rigid transformations, you're just moving the shape around. You're rotating, reflecting, or translating. And they create congruent figures, which mean the same size, the same shape. But a dilation is just making a similar figure. So what that means is you're still going to have the same shape, but it's going to be a different size. So dilations make shapes bigger or smaller. Now, in math, similar means something very, very specific. So I'm going to give you the definition of similar. Put that in a box. In order for shapes to be similar, it can't just be any two triangles, right? In regular life, we might say, oh, yeah, all triangles are similar. They all have three sides. But in math, it's got to be very, very specific. In order for figures to be similar, they have to have, the angles are congruent. So even though you make the shape bigger or smaller, all of the angle measures have to be exactly the same in the pre-image and the image. But the side lengths are going to be proportional. And I know you don't know what that means, so that is our next vocab term, proportional. So proportional means, the only way I can think to explain it is that corresponding sides all reduce to the same fraction. So I'm going to show you what that means. So we're going to draw a small triangle, and then we're going to draw a larger triangle. And in the small triangle, the sides are 1, 2, 3. And in the larger one, they are 3, 6, 9. So we need to find the corresponding sides. So the small side here is 1. The small side here is 3. I'm going to give them both a tick mark. And those sides make the fraction 1/3. Okay? Now for the medium side, here it's 2. Here it's 6. The fraction they make is 2/6, but I can reduce that. I can make it smaller by dividing numerator and denominator by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So these reduce down to the same fraction. So far, those two corresponding sets of sides are proportional. The last side, the long side, is it gets 3 tick marks. It's a 3 there. It's a 9 there. We get 3/9. I can reduce or make that smaller. This time I divide by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. All of the sides reduce down to the same fraction. So these triangles are similar because the angles are the same. So here we have a 90. I don't know, say this is a 30 and this is a 60. So the angles are exactly the same, but the side lengths, even though they're different, they reduce down to the same fraction, so they are proportional. One last vocab term, and then we're going to do page 83. Scale factor. This is in our objective. We use a scale factor to do the dilation. So there's two kinds of scale factors. If you have a scale factor less than 1, the figure gets smaller. So for example, 1/2, 2/3. Those are scale factors that are smaller than 1. Or you can have a scale factor greater than 1. And that's going to make your figure bigger. So scale factors bigger than 1 would be like 3/2, 4/3, 2. Okay, so that's it for notes. Next video will be page 83.